pledge allegiance
to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Thank you. Roll call, please, Liz.
Mayor Dickey,
Here.
Vice Mayor Charnow,
Here.
Councilmember Tolas, Councilmember Brown,
Here.
Councilmember Magazine,
Here.
Councilmember Friedel,
Here.
Councilmember Spellich.
Present.
Thank you. So Grady, are we going to start with you and then we'll
Yes,
hear all-
I'll lead off and give a little introduction before I turn this over to Rachel. So Mayor and Council, before you tonight, you'll be hearing a presentation on the fountain, the lake, and essentially the park as it relates to the irrigation system. As you know, that the fountain is basically going to be 50 years old on December 15th. There is quite a bit of investment in this. In fact, this is probably the second or third most expensive asset that we have in town. We have our streets, number one, these facilities, these buildings here, and probably the park, lake, and fountain is probably the next in terms of value. As you know, these facilities are aging, and we know that the liner that was put in about the year 2000 had a 30-year life. And so with this being the 50th anniversary of the fountain and the fact that we've had some failures with some of the components, we thought it was very important to just have a very deep dive into evaluating the lake and the fountain and look at that. And then also have a look at what it's going to take once it's time to replace that liner. The last time we replaced the liner, we had some, the ability to use another facility to get rid of some of that excess water that the lake has. So with that, I'm not going to go too much into this. I will tell you that the firm of Black & Veatch was the firm that actually helped us with the lake liner the last time. And so they have quite a bit of history with the town of Fountain Hills and Fountain Lake. And so they're very well qualified to help us with this. Again, our purpose is to get an understanding, an idea as to the condition of these assets and what the replacement might ultimately be. And then we'll come back at a later time, probably through our capital discussion about sequencing and what we may want to do in the future as far as how to address financing and paying for these improvements. With that, I'm going to turn it over to Community Services Director Rachel Goodwin, who will then briefly introduce our consultants.
Great. Good evening. Thank you. Our town manager really did sum it up. Tonight is really a benchmark of where we are at today. We won't be discussing the logistics of what we need to do or when we need to do it or how it's going to work. Really tonight is to review what condition our fountain is in, our mechanical systems, our electrical systems, and any immediate threats to those. We'll be coming back at a later date to talk about the wheres and the hows down the road. So wanted to just make sure that that expectation was out there. Please feel free to ask questions. Last thing I did want to note was that we have been working with the sanitary district. We've met with them. Dana's been part of this conversation. So everything that we do talk about tonight, they are in, they've been participating in and have really facilitated getting us to this point. So just wanted to thank them for their time as well. In the meantime, I'm going to introduce John and Mike. They're with Black & Veatch. They have been integral in helping us get to where we are and have been very good at helping us understand in what I call an engineer is helping a non-engineer understand what we're looking at. And so I think they'll be able to help to do that tonight as well. So with that, take us away.
Hello, thank you. I'm Mike Caruso. Thank you, Town Manager and Mayor and Council. Thanks, Rachel, as well. I'm the project manager with Black & Veatch, and John Corbin is my counterpart here, who will also be discussing with you today. But it wasn't just us. We also actually had some assistance with some subconsultants. J2 Environmental, or Engineering and Environmental, helped us with the irrigation assessment. Rubicon Applied Divers, who are local here to Fountain Hills, did the diving services in the lake itself. Construction product marketing helped us with some remote video cammering of pipelines out at the pump station and at the fountain itself. And Arizona State University lent us their evaporation pan, which John will go into a little bit more. So with that, I'll talk a little bit about our agenda tonight. Wanted to talk a little bit more about the overview of the project, a little bit more specifically about the lake itself, the criteria that we spent, that we used to do the assessment of all the assets that we looked at, and the weighting of those. And then ultimately the findings and the recommended improvements that we found. And we're not going to hit every single one of those, or every asset that we looked at, but try to hit the highlights. But if you have specific questions about any of them, again, feel free to ask us along the way. So as you mentioned in the introduction, certainly the fountain is quite important to the town and is the mainstay of your community. What we were charged with doing was really assessing the assets of the fountain. It's not just the fountain itself, but there's a lot of mechanical and electrical systems, the liner itself, as mentioned, and the irrigation system to beautify the surrounding turf around the lake. And then ultimately, what are those recommended rehabilitation and improvement options that you have, and which ones would we think that would be best suited to do both in the short term and then ultimately long term. So with that overview, we'll go through just some of the components. We'll see some pictures of what we looked at, and then we'll go into a little bit more about the scoring criteria. So certainly you typically don't see a picture like this. This is below the water surface. There's a lot of moving parts and some non-moving parts as well, but ultimately that mechanical equipment to aerate the water so it doesn't go septic, and to move sludge around to where that it's not piled up in big areas. Ultimately, there are things, the liner itself, and then in the pump station, the mechanical room, it's got the electrical equipment, all of the pumps, which you see here. These are one of the 3 large vertical turbine pumps, and the picture to the left is the actual check valve that prevents water from coming back after the water is pumped out. The Lily structure itself it's actually a lot larger than it looks since it's so far away. There's a nice platform that's out there as well. It's a concrete structure. We looked at the concrete itself, the nozzle itself you can see in the middle of the grading structure on the left. And I know there is some other projects that are ongoing to upgrade the lighting in that area, so we did not include that in our scope. That's done separately. The irrigation system itself, within that pump house room, there's a separate skid with the pumps that supply the water, also pull it right out of the lake and send it to the irrigation system. The irrigation controller is pictured on the right. And then the electrical equipment as well. So there's main motor control in the center. The power that you get from the utility is fed through the one on the right. And then from an instrumentation and control and INC standpoint, the control panel itself is the small inset picture on the left. So again, all of those things we'll talk through. But one of the things that we wanted to talk with the team about was, how do you assess those different types of equipment? Those are all different things. How do you rate them? How do you rank them? How do you prioritize them? So what we did is we came up with some assessment criteria and associated weighting factors. And they fall into 2 categories. One is the likelihood that something might actually fail. So you can see on the left-hand column in dark blue, there are major criteria that we utilized from the asset's age, its condition, its performance, its reliability, how easily it's maintained or able to be maintained, and is it redundant? Does it have a backup? And each one of those in the column next to it, you can see along the top, that was given a weighting percentage. So some of those are more important than others, so they got a little higher weighting, and we worked as a team to establish that weighting criteria. And then you can see along the top, as you go from left to right, a score of 1 to 5, 1 being the best and 5 being needs improvement, I guess you could say. So ultimately what we did is for every piece of equipment that we assessed, we used this criteria. How old it is in relation to, say, the manufacturer's typical recommendation for the life of that typical piece of equipment. And so just to give you a quick example, this likelihood of failure score, we took this particular pump. This was one of the irrigation pumps that is on the skid that's in the pump house. You can see just physically from the picture itself, it's seen better days, right? And in talking to Kevin, that had already been on the list to be replaced. And since we've done this, it has been replaced. So that was already on the list. But this was kind of a snapshot in time. So we could see that we gave it, from an age perspective, a score of 4. So it's more likely to fail than not likely. It's a fair condition. You can see just from the picture itself, it's not in the best of shape, although there is some rusting, but it's not completely gone away, right? It's still usable. Its performance hasn't been able to meet what it was designed to do. And then the reliability and the maintainability both were scores of 3 right in the middle. But because there is another pump that's there that is fully redundant, it actually had a negligible score on that standpoint. So if you take all of those things and multiply them all together, you get a likelihood of failure score of just over 3.1. And the other criteria that we weighted against is what's the consequence of it failing? So it's not just, is it going to fail, but what happens if it does? So again, similar type of thing, we identified these. Yes, please.
Sorry. Did you assess how long it might take before it fails?
So to answer your question, council member, is how long it takes, how long some of this equipment might take to fail. Right. That's kind of baked into the scoring. So the higher it is on the scale, the more quickly it would actually fail. So I should say that of this picture that we showed is probably the extreme example of something that was close to failure. Everything else that we saw out there, while its age might be beyond what the manufacturer's recommendation would be for a typical age of piece of equipment, there was nothing that showed imminent failure, if that makes sense. So from that standpoint, we didn't necessarily pinpoint this has 2.6 years until failure.
That was my next question.
Okay. Sure. So from a consequence of failure standpoint, again, we came up with these 5 major categories from it. What's the impact to the environment? From a safety and security standpoint, both for town personnel as well as the public. What's its impact financially? Does it have any regulatory compliance impact? And the biggest weighting factor that you'll see there is what's the impact to society or to your community? And again, 1 being the best score, 5 being the lowest. And again, looking at that pump in particular, it had a medium impact from an environmental standpoint, so it was given a 3. From a risk of safety or to the public, it was given a low risk, so it was a 1. its financial impact, yes, there is some impact to that. It might require that of an outside contractor to help replace that, or is it greater than a $50,000 cost? And then from a regulatory compliance, again, there's no, if that pump failed, you still have another redundant pump, and it wouldn't impact the environment if it did. And then ultimately, though, it did have a higher score from a 4 from an impact to society. So if there were multiple failures and it wasn't able to deliver water to the irrigation system and to the turf, then ultimately that would have a negative impact to the community.
Mayor.
I have a question. Oops, sorry.
go ahead.
Oh,
Yes,
I was
please.
going to ask you, the weighting, the social community weight is higher than the safety security. Is that because safety security is gonna get the attention anyway, or how did that weighting get figured out?
Good question, Mayor. From what we felt was most of the equipment is either submerged in the lake or behind a secure environment. So from that standpoint and talking to the team, the weighting factor and the more importance was placed on what's the impact to the general public.
Thanks, because it's more controlled. I mean, who's going in and they can evaluate what they're doing rather than if it was out in the public somewhere.
That's correct.
Thank
That's
you.
correct.
Councilman?
If something, if equipment has, you think, a 2-year life, let's say, did you look at all at whether or not you can repair them rather than replace them?
Yes, we did. We looked at, and you'll see in some of the later slides, from a recommendation standpoint, if it had the ability to be refurbished, that was the recommendation. If it was beyond or nearing the end of its life, then yes, from replacement, if that made more sense. And we have a couple examples of that. And in a lot of cases, it was just continue doing what you're doing, maybe add an additional element to your operation and maintenance schedule that you would do over the course of the year that Kevin and his team typically are already doing. Okay. So we did that for all of the assets that we looked at, and you can kind of see them on this plot. So this was the blue triangles are the individual assets associated with the irrigation system. The orange squares are anything that's civil mechanical related, the pumps themselves, and anything in the gray circle is electrical related. So just to orient you a little bit on, let's see if I can get my mouse here. There we go. So you can see my mouse, hopefully. Along the x-axis is the likelihood that it would fail. So 0 being it's not going to ever fail, or it shouldn't fail at any time soon. 5 all the way to the right being the most likely that it would. And then again on the y-axis, the consequence of failure. So what happens if it does? Again, 5 being the biggest impact. So what we see is if it's most likely to fail and the highest consequence, it's up here in that upper right quadrant. So those were the ones that we wanted to focus on, but you can kind of see that as you would expect with equipment that is the age of the equipment that we have, most of them are kind of in that upper right-hand corner anyway. And again, as I mentioned, that this is kind of an evergreen process. So this was just a snapshot in time at the beginning of the summer that when we did this assessment, there have been pieces of equipment that have already been replaced. So the consequence score wouldn't necessarily change, but if it's something has changed, oops, let me go back one, sorry. Find my mouse again. There it is. So say if this particular piece of equipment has been replaced, the consequence stays the same, but its likelihood would simply move to the left and have a less likelihood of failure. So with that, are there any questions about, I know this charts and graphs and lots of things, but any other specific questions about those?
I don't, so each one of those represents a specific thing that you
Correct.
have in your report, like,
Correct. Each one is a specific piece of equipment. So with that, we'll talk a little bit more about specific, not every single one of those, because there's a lot of dots up there, but we'll talk first about the civil mechanical system. So with that, I'll turn that over to my colleague, John.
Thank you, Mike. John Corbin with Black & Veatch. Was assisting Mike in the role of engineering manager. Very pleased to be here and not stuck in my office as usual. So as Mike was relaying, we want to start by talking about the nuts and bolts, mechanical stuff. That's my area of expertise. As he went through in the introductory slides, we took a look at all of the equipment at the pump house. We took a look at the major components there. We took a look at the lake liner and the fountain lily structure, and even the pipeline between the pump house and the fountain. And we're not going to get into the nitty-gritty of every component, but we'll touch on the major assets here. So let's start with the lake liner, because I think that's of greatest interest to many folks. As Mike mentioned, we sent divers down to take a visual, firsthand inspection of the HDPE plastic liner that was installed 20 years ago. We also had them take a look at where the liner meets the concrete that surrounds the lake, and that would be represented by this photo here. This is back in 2000 when we installed the liner. And furthermore, we had them take a look at the subsurface intake to the pumps at the pump house. So let's talk a little bit about what's going on here. The liner is a plastic HDPE liner, and it's fastened to the concrete with stainless steel batten bars and these anchors. And we identified, we identified for the divers certain locations around the lake that we wanted them to examine the connection. And the feedback we got was all of the connections were in very good condition. They identified, one or two missing anchors. Most likely, those anchors were never installed in the first place. If you've ever drilled concrete, sometimes the drill is just refused and it won't go. So they moved on to the next hole. But overall, very positive feedback. And that goes for the liner condition itself. So they went out to the middle of the lake at certain spots that we identified and took a look at the liner condition. There were no tears that they observed. There's no folds, creases. Overall, very positive view of the condition. But we'd always planned to go a step further and do an evaporation test on the lake as a whole, because we can't, expect the divers to inspect every single square foot of that liner. It would be very easy to miss some damage. But by doing this evaporation test, we measure the loss of the lake over a period of time and compare it with the loss of a controlled evaporation pan. And there's a little bit of a conversion factor in there because you got a small body of water next to a large body of water, and they're not one-to-one, but there are accepted practices for doing that. So you look at the graph, and there's great correlation between the pan evaporation and our measured lake evaporation. But key here is that we actually measured a little less of a drop in the lake than we did in our controlled pan. Now, there's lots of factors, error of uncertainty of measurement, that kind of thing that comes into it. But the key is that if we had seen more of a drop, that would have been a concern that we've got a loss that we don't know about. But we saw just the opposite, and it gives us a pretty good feeling that supports the liner's in great shape, and there would be no measurable losses accounted for as far as leakage from the liner. So everything's great in that regard.
How much is, in gallons would there be? Do you know?
Over the course of the test period, how much gallons did we lose? I do not know that off the top of my head, and I can't compute that off the top of my head.
Just curious. Sanitary district probably knows.
Oh, yeah, but no, she was asking gallons. I don't know how many gallons.
Per inch.
Yeah.
Come on. Thank you.
No problem. So as I mentioned, we also sent the divers over to the intakes that are beneath the pump house. And we had already known that there was some concern about the screens. The area under the pump house should be screened off to keep large debris out of the pumps. But since one of the pumps had recently sucked up a large fish and had to be fully dismantled to remove those fish parts, we knew something was awry. And what they found was one of the 5 screens was completely bent back into the intake area. So effectively, there was no screening. It's not difficult to understand. We would recommend that get repaired right away, and we're actually working with the divers right now to come up with an approach for that repair. So above waterline, we took a boat out to the lily structure. And yeah, the lily structure is covered with organic and inorganic material. It doesn't look pretty when you're up there close, but we could find no evidence of major structural faults with the concrete. There's some spalling in areas that I'm pretty certain were locations for the original anchor bolts when they hoisted that thing into place. But that's not a terrible, concern of mine. Like Mike mentioned, the lighting was in poor shape, but we already knew that. So, our recommendation is just to continue to monitor and spot repair as needed. But furthermore, when it does come to a time in the future when the liner gets replaced, and that will happen someday, we would really recommend that an intensive cleaning of the structure would be warranted to get a little better, a more in-depth structural review of the concrete that, it right now is just kind of covered in muck. Oh, here's those anchor bolt locations I was mentioning. So really, they're just tiny little divots in the concrete. So let's talk about another big one, the fountain pumps. When we initially entered the pump house to start our mechanical assessments, it was pretty apparent, they needed some work. They needed some love and attention. But we weren't ready to say scrap them. We already knew that one of the pumps had been removed and was at a shop for rehabilitation. And that was great timing for us because then we could see the level of rehabilitation that was being done. We went to the shop and talked with that shop to discuss what are you doing to the pumps? how are you doing it? And we were very pleased. You can see here, yeah, it's pretty looking, but more than that, this rehabbed pump has, to our satisfaction, been rehabilitated to the level it needs to be. So we're comfortable with a recommendation of continue this same maintenance, the same course of maintenance, and we don't feel that these just need to be scrapped and replaced anytime soon. You should get more years of life out of them with what you're doing. Yes. Now, here's another
I have a
sore
quick question,
spot.
I'm sorry. So
Yes.
how much would a new one cost?
Oh, gosh. A
Generally.
vertical turbine, multi-stage like that? Oh, did you? I would have guessed higher.
And put one in it, and and rewinding the motor, and then a new pump, it's about $50,000.
Okay.
What about the pump cost to replace?
That was the pump and the motor when we did that.
But that wasn't a complete
Not
replacement.
complete replacement, that was.
So it would be a little higher, because you're not talking replacing the shaft or replacing, or the column and the head.
Yeah.
Your legend is showing it, if you go back, it's showing it's greater than $500,000, so I just want to make sure we're understanding that correctly.
Yeah, if you did total replacement, that, we rebuilt the motor when we did.
Well, it's less than a half, but greater than 100 is the five.
Oh, okay.
Yeah, for all three.
For all three?
Right,
Okay.
For all three, not each.
yeah,
Okay, thank you.
sure. So here is another sore spot that some of you may have been hearing things about. The check valves on the discharge of these pumps are there to protect the pump. If you have pump 1 offline and pumps 2 or 3 are operating, you don't want water backflowing down your pump. That's, really their main purpose. We wanted to, other than just a simple replace it recommendation, we wanted to understand, why are these check valves failing after only 3 years? Because I know that's been a question on everybody's mind. So we were able to actually, open one up and take a look at the guts. We observed material loss, both in the closed direction and the open direction. So there's a lot of banging going on inside of there. And the progressive material loss is why it will stick open. And this has been a real headache for the operations staff. Unfortunately, with the system, if one of these sticks open, the position switch on the exterior of the valve will fail to close. And what it does is just shut the entire pump station down. So instead of just, affecting the one pump and the one valve, well, now your fountain's not running at all until Kevin goes out and basically jiggles the handle, just like you do on your toilet at home, to get it to seat. And it's not convenient, as you might expect. So, yeah, that's right, the jiggle the handle job. So, in addition to the interior damage that we saw, we took a look at, the valve itself, and it was never really an appropriate selection in the first place. Not the style of the swing check valve is perfectly fine in most situations, but this particular valve wasn't rated for the pressure of the pump system here. So that's why we're stepping back and saying, you really need a valve that's had some thought put into it. And this is going to be more than your just commodity off-the-shelf check valve that you could use in a lower pressure environment. it's going to have a little bit of a cost impact because it's going to be a higher pressure-rated valve.
Thank you, Mayor.
Yeah.
So 3 years ago, Kevin or Rachel, when we replaced that, who told us to put that valve in there, and why are they not responsible for giving us bad information?
Well, and this, sorry, John. We may be stepping over, this is our next item, but to clarify,
And it was 5 to 6 years ago.
yeah, they started
So it
about,
wasn't
we
3
were,
years
we were
ago.
replacing them, we didn't do them all at one time. We did them individually, one after another in successive years, because we couldn't absorb the cost. My guess is, and I wasn't in the director role at the time when this started, but my best guess is that we worked with our vendor, or an electrical vendor that works on our pumps and our systems regularly. We said, hey, we're having issues with our previous valves, which is the one up there on the left. We're having issues, it's sticking all the time, we're using a lot of clean water, we're having multiple problems, we need to replace it. They said, okay, we think this is the best situation. We did not have an engineer involved at that point, from what my best guess would be, is that we went with the engineer, with the recommendation of the service provider, and there was a disconnect as to exactly how much pressure and how much volume moves through those pumps. So that would be my best guess,
So we asked an electrician a plumbing problem question.
maybe.
Good way to put it.
And Rachel, what was do you remember what the original warranty period was on those valves at that time?
My guess is probably no more than a year.
And what did we pay to fix that?
Each valve at the time was about 8,000, if I remember correctly, when we went back to do some historical research. So each one was 8,000, and it was absorbed in the operating costs of each of those years. That's why they did one at a time.
And if we replace it correctly now?
We're looking at probably in the wheelhouse of about 25 grand a piece.
So you get
However,
you get what you pay for.
kinda.
Let's fix it right.
Yeah, I presume in the future, as we do make any replacements, before we make the replacement, I assume you folks would be available to take a look at what we're thinking about replacing them with?
Yeah, well, and I'll go through this right here. I mean, we've made a selection for you. There was some discussion, about, well, could we just give the town a spec and then they can shop it around? And we just decided to cut to the chase and say, this will work. And we've contacted the vendor, we got the quotes. So, yeah, they're.
For how long will it work?
Well, how long is it expected to work? These ought to work for 15 years. It's going to have a 1-year warranty like every piece of equipment does. But we're confident that this is the appropriate valve, and you will be able to maintain it appropriately and, even rebuild it later down the road. You will not start to see material losses on the inside of the valve because it's not the right valve. So I think we've stole my thunder here on this slide, but I'll go through it here. Anyway, no. So, as we were talking about, this was the previous style valve, and generally it's just called a diaphragmed control valve. Clay valve is a brand, but this style of valve can be had from other suppliers. And it's frequently used by municipal water suppliers to control pressure in their distribution systems. And it can be used on the discharge of a pump for pressure control. But what's key is that it have a clear water supply. You can see from the little picture, you've got a lot of little tubes and appurtenances stuck on top of this thing. It doesn't do well with dirty water. But it sounded as if when these were installed, they did have a separate clear water supply. Regardless, it sounded to be a maintenance issue, repeated clogging issues. It wasn't a good fit. And frankly, if we were starting with the blank page design, this kind of valve we would never be suggesting. So it's curious that It was used, but we wanted to dispel any thoughts that it worked really well, so why don't we go back to it?
Mayor?
Um,
Yeah. Excuse me, I'm sorry.
Yes, yes.
We have a lot of salt in the water. How might that affect any of this equipment?
You know, these are lined appropriately, coated. So salt buildup shouldn't really be an issue, nor corrosion if you continue to maintain your coatings. You know, it's not a seawater application, but yeah, the high TDS of the lake really shouldn't be an issue for these valves.
Have you had experience with other lakes or anything with a lot of salt?
Well, we've certainly had, you know, experience all the way up to true, you know, ocean water pumping in our company. And, you know, yeah, at that level of salt, you start to get into special coatings. We don't really have that situation here. It's not a concern.
Thank you.
Sure. So let's jump from, you know, what was to what is right now. You know, was replaced with a swing check valve, and like I had mentioned, that doesn't necessarily mean all swing check valves are a terrible, you know, application for this. It just happened to be that this really wasn't rated for the job. So what we're proposing looks an awful lot like what you've got, but all the internals are rated for a 300 PSI operating condition. And we're going so far as to also suggest things like an integrated damper. So think of kind of like the shocks on your car. It kind of helps to control movement. This would help to control violent swings internally that could damage the inside of the valve. And this is integral to the valve. Also, we'd be providing a position switch that was integral to the valve. If you take a look at what has been done here on the existing valves, the position switch was kind of an afterthought, and it hasn't worked terribly well. It's just kind of sitting there on a little post. So we would move away from that kind of a installation. So, you know, to kind of reiterate what you had just mentioned, yes, there might be a little bit of economic impact, some soreness there, but you're going to get a heck of a lot longer run out of this, and it's the right application. So I will just do my best to give you the overview of the irrigation system that J2 assessed. And, you know, when I take a look at this graphical summary of the assessment, each individual item may look like, well, gee, most of it's in fairly decent shape. But I think what we want to do is bring your attention to the system as a whole that needs to be kind of evaluated maybe in a little different vein from just looking at the piece parts here. So we've been told that, hey, you know, one of the biggest sources of complaints that we're going to get is from the public perception of the turf quality and the irrigation. Morning and afternoon walkers around the lake don't want to be hit with irrigation spray, and they're going to say, why can't you do this some other time? You know, and if there's rough spots, they're going to complain about that too. So irrigation becomes kind of a higher priority item than you would think. And that was kind of covered in our, you know, consequence of failure discussion earlier. Did you have a question?
I do.
Yeah.
Back to the salt.
Yes.
The salt is just ruining all the grass. Is there anything mechanical that can be done to reduce it?
Well, Kevin's done a great job in developing, honing in on chemical treatment, and that is going to be your best option because mechanically, well, how do we remove the salt in our homes? By an RO system. And, what we do in our homes is we actually take that concentrated salt and flush it down the drain. On a large scale like this for the lake, what are you going to do with that salt is a big problem. It's always a problem when it comes to desalination types of projects. So it's not really a recommended approach. Yeah. Besides, the cost would be astronomical.
I was hoping to get a different answer.
Yeah. Understood. So anyway, as I was saying, the complaints focusing on, well, why can't I walk around the park without getting wet, kind of come back to the design capacity of your system right now. We've got, I guess, a 12-hour, nearly a 12-hour watering window because, well, the pipes are a little on the small side and the pumps are a little on the small side. And all of those are factoring together. Well, Kevin can only do so much and still get things watered. So there's a focus on, well, let's reduce the water window. And that can only be done by some irrigation pump replacement and expanding the size of your distribution mains. And this is all, in conjunction with the fact that it's become a maintenance nightmare because they're regularly out there cleaning irrigation heads because they're clogging. I think the system's so old that it's got a whole lot of material buildup inside. Stuff that they're not necessarily seeing at the pump house, but they know ends up reducing the range that their sprinkler systems will shoot, because things are clogging up. So there's a lot of those factors to consider. And so as a whole, our recommendation is a pretty sizable upgrade to the irrigation system. Controllers to better offer more flexibility, main size increases, and pump size increases. Now, the good news is, of course, you don't have to spend all of that money in one fiscal year. You can, have a replacement budget on an annual basis, but one thing to note with that approach would be you may not be getting all the benefit that you're looking for when you do piecemeal it out until everything's in place.
I have a question about the option about using the non-lake water.
Yes.
That wouldn't solve this issue necessarily, right?
Yeah, unfortunately, it creates more issues, other issues, I should say. So yeah, I wanted to briefly touch on that. So we had talked with the sanitary district about this idea of, let's look at taking water directly from your AWT site, your advanced water treatment facility that's just down the street. And, don't put that water in the lake, but rather direct feed it to your irrigation pump system. And that, that would solve a lot of your irrigation quality problems. The danger is now the lake as a whole has become just a dead end. It has water going in and no water going out. And we would be concerned about the long-term water quality of that approach. Would you get to a point where your fish would not survive anymore? So we're going to address that kind of thing in the report. But yeah, that's a topic for discussion.
Do we actually plant special fish in there, or is it just all goldfish from carnivals in the valley?
Yeah, I think it's just a lot of carp, and turtles, right? Yeah, and if I recall from 20 years ago when we did this last time. Yeah, it was just a lot of carp, and I think we had a conservation group come out and take the fish away. Well, I'm jumping ahead of myself here, because we're not planning on discussing that right now, but certainly we'll be discussing it in the report on the what-ifs and how do you do this.
Because, I mean, I think SRP uses certain fish in some of their canals.
I don't
and
know if there was that much thought, right, because it cleans
just wondering if
algae.
it's
Yeah, I don't
a
think
possibility down the road. I'm just asking.
Yeah, you'd have to do an assay, I guess, of the kinds of fish that are in there.
I have a question again. Just to be clear, if we did decide that we wanted the separate storage, that still doesn't solve that we have to replace all the irrigation.
Right, no, this would be in addition to, yeah.
Just to follow up on Councilman Sharno's question, we do not actively stock the lake currently. We have in the past. There are a number of different fish in there. When we did a lake quality assessment a number of years ago under Director Mayer, it was identified that we probably have 4 or 5 kind that do exactly what you're talking about. They're sunfish, and I can't remember all the different kinds off the top of my head, but there are a number of them in there to help with that specifically.
So there was some thought.
There was at some point in time.
Okay, good. That's good to know.
And,
We
and,
do have a lot of goldfish and turtles.
Yeah.
and Mayor, if I may, Kevin, if you could just come up to the podium, can you just kind of talk about operationally the issues, like how long it takes to irrigate the park? Because I don't think people realize we have only like 1 or 2 zones totally, and it takes from beginning to end, it takes numerous hours. So you want to just kind of explain how that works?
Certainly. So on a typical night, we're running 6 different controllers that are running 45 valves. Each valve is running 4 to 6 sprinklers at a time. And those sprinklers are throwing 70 feet each. And so our water window ends up being, and the computer maximizes the time as best it can, but as we were discussing earlier, with an undersized system, it can only do so much. So we start out at a 10-inch line, but then we drop to an 8, then we drop to a 6, then we drop to a 4. And so it drastically reduces the amount of valves that can run in those sections. Our water window right now is between 11 and 12 hours during the heat of the summer when we're running. So we start at somewhere around 10:30 at night, and we end sometime around 10:30 in the morning. Along with that, just the day-to-day maintenance of cleaning out the heads. We figure Joe, who takes care of the park, does a fantastic job and works like crazy, and most people know Joe. He's probably spent somewhere in the 15 to 18 hours a week just cleaning heads. And when you start thinking about all the other things that are going on in the park, and he's pulling out that kind of time just to pull out heads to clean them, and that's not getting all of them, that's getting the worst of them, and then continually trying to keep up with that. It's a very difficult task. We've done a lot with the chemical injection. For those of you that have been here 3 or 4 years, you've seen that we've made a lot of strides in it, but it's also a very difficult task to get to where we're at, and we will continue to improve, but it's a matter of, it's not easy doing what we're doing with the staff size that we have and the quality that we're dealing with.
Yeah, that's been a problem forever, is cleaning those heads and heads that fail and replacing them and so on. What is he not doing because of that? I mean, are things that fall by the wayside that we should know about?
Sure. The biggest thing is it's a constant, it's the number one thing you see, right? So it's always the top priority. If all the turf's brown, everybody notices, it's not like it's second on the list or third on the list. It's always number 1. Number 2 is probably cleaning the sidewalks this time of year when the coots all come in, right? Everybody hears it. So you got to pull time from different things, cleaning the, just general cleaning, trimming, blowing off the walks, everything. Everything else loses a little bit of time, so you can gain as much time as you can to make the number 1 thing look the best. That's the best way that I know to manage how we run the park. And we send over extra help. We try and get extra people there to help, but then you're just pulling from somewhere else, and so you're constantly doing that give and take. And and we do the best we can with the small crew that we have, but it's definitely a difficult task.
You do a great job.
Well, thank you, appreciate it.
Mayor, if I may.
Yes, Councilman Brown?
Thank you very much. So can anybody tell me who did the engineering? Probably 12 years ago, they put an entire new irrigation system around the lake. Who did the engineering on that?
I believe it was Coates in Irrigation that did that. That's what all the plans have on them anyway.
And we're that deficient in water today?
Yes, that's my opinion. If we wanted water in a window that's less than that amount of time, which I think would be the best for the park for sure, because we have people that walk up till 11 o'clock, 11:30 at night, and we have people that come in at 4 o'clock, 5 o'clock in the morning, and it's not a small number of people, it's a relatively large number of people, and so that to me would increase the usage, and you know, it's definitely the complaint that we catch on both ends of that. Why aren't you watering later, and why aren't you watering earlier? You know, so I don't have a way to win and keep making the improvements that we're making in the turf.
So I'm one of those 4 o'clock in the morning walkers, and I clearly understand. I take a shower after I get home.
Right.
So it's interesting. Do we have an estimate on what it would cost to redo yet again the pumps and the irrigation systems around the park? A guess?
At this time, we're just kind of doing the assessment side of it, so we don't really have those numbers.
Estimate was? Mike, do you remember?
It was a lot, it was farther north of $500,000 than what was shown. So I think it was, I could pull up that information on our
If you would, please.
Yeah, we have it with the, on the slide also. I'm sure that these aren't like exact numbers, but it does have the $6 sign, so, yeah. Councilman?
Kevin, would it be safe to assume, I know you shouldn't assume things, that the bigger heads will flush themselves out and be less maintenance for you guys, or is it just the whole system that's?
Yeah, it's more of a system-wide issue. The size of heads, we're using heads that throw 70 feet. They're a good size head. They are a golf course quality head. And as we were discussing earlier, so we've been doing tests the whole time that I've been here, trying different things, 10 different ways to see which one's the best, because that's what we want, right? We want to do the best that we can with the money that we're spending. So even right now, I have 2 different vendors that are bringing out some free samples for us to try some different things and see if we can get something that does work better. But in running, we brought in some filters and we put a single filter on a single valve and ran it, and it got clogged within 2 days. But then we're just blowing out 1 filter versus 5 heads, right? So we're saving some time. It still stinks, but it's better than what it was. And so now we took that same filter, a different filter, but the same style, and we took it over to the pump, and we hooked it up directly to the pump before the filter that runs the entire system, and ran it through it for about an hour and saw nothing in the filter. So that tells me it's in the lines and not actually in the water, which means we have a system-wide problem, not a lake problem that's causing this. So that's why we're continuing to try different things out in the field to see, because we know what size it is, and when we pull it out, we see it all the time. We know that the acid does break it down, but it's really slow. And when I got here, we were having to literally take air compressor and blow it through the lines to get the stuff that's clogging the heads to even move out of the lines, because the water pressure wasn't enough to move it. So that gives you an idea how clogged they were when I started. We've got through that problem. We haven't had to pull out the air compressor lately, but what we have had to do is clean out the heads on a regular basis to keep that system running so that it doesn't get that clogged again. So it's a day in and day out type of problem that the grass isn't very forgiving to. When it doesn't get water and it's 115 for 50 days in the summer, you see those spots where we have the problem, and it's continually the same areas that we have problems in. So I got several different professionals that are trying to help us find different ways, and I'm willing to try almost anything if they're willing to let us try it at a good cost or no cost. Why not? So we have definitely been doing a lot of testing, trying to find better ways to do the way that we run the place.
Mayor, if I may.
Yes, go ahead, Dennis.
Thank you, Mayor. This is a general question. Is the sanitation district trying to help us resolve any of these issues?
I'll take that, and then Rachel might be able to add to it, because I know Rachel's been involved in working with Dana, the executive director of the sanitary district, but they have offered to provide some technical guidance and assistance. We have had some preliminary discussions about a water storage system. You know, I think they're open to the discussion. I don't think that they really want it on the advanced wastewater treatment plant's property, but Dana has given me some good advice as to how we might be able to do it over at our park. So they seem to be wanting to be engaged, and as part of this whole process, they've actually have worked closely with the consultant team and meeting with them and providing some good input.
Yeah, and the other thing to remember, Dennis, the other thing to remember is that when we're getting that water and they're pumping it into the lake, and it's been getting pumped in there for 20 years, we have 100 million gallons in the lake. I just ran some figures a month ago, and we're using about 60 million gallons in a year's time. So during an entire year's time, we don't even turn the lake over one time. So that just means that more and more salt is getting put into the lake, and then as it evaporates off, it just leaves more salt behind. So just to give you an example, the water that we get from the sanitary district for, say, Golden Eagle Park, where we turn it over all the time because we share it with the golf course, it gets turned over several times a week. We run about 200 parts per million sodium and salt in that water versus 600 parts per million in Fountain Park. And that number is just going to continue to climb over the years, and it's a slow, steady climb. So, you know, it's just the nature of the beast. When you're putting salt water in and it evaporates off, it's going to continue to get worse until we completely drain the lake and then refill it, and then it all starts over again. That lake was originally being used to water all the golf courses and our place, so it was getting turned over more. Well, it's not anymore. We're the only ones that use the lake.
And so, and that's the point. You know, the sanitation district cannot exist without this lake, and we know that. And I can't believe that we cannot get more assistance from the district to help resolve this problem, or at least contribute to it. And that's a Grady question.
Well, and Dennis, so I think really the key here is this assessment, so we can know what we really need to ask for. So without having that and having estimates and being able to have a serious discussion, I think this is a perfect topic for a joint meeting between our council and our sanitary district board with sufficient.
I've heard that for 20 years.
Well, I'm sorry, I haven't been here 20 years, but we're doing a first-time lake assessment, and I think we're getting some really good direction from some engineers who know what they're doing here.
Okay, that's fine, Grady, but this is not the first lake assessment Fountain Hills has had, and the sanitation district has not held up their hand and said, hey, listen, we can help with this. And I think that's really disappointing.
I hear you, and we'll try to continue to work through with the district on this.
Vice Mayor?
Okay.
Thank you, Mayor. Just getting back to the irrigation, so you said it's not the water itself, it's the pipes? Is there like compromises in the pipe or leakage? I'm not following
So
what
it's
what the
over time.
clogging.
Yeah, it's over time, the sediment that was built up in the pipes is now flaking off basically and sticking to, and then getting caught in the filters of in each individual sprinkler.
So there's still a lot of sediment inside the pipes,
Right.
you're saying?
Yeah.
Okay, wasn't
Yeah, it
quite
was,
following that, so.
that's where I was saying it was so bad when I got here that we were
Uh-huh.
literally taking air compressors
Compressor, yeah.
to add the extra pressure, and then we were blowing it back and forth between two heads, just trying to get it to move enough so that we could get it to blow out, because the 100 PSI that we're running wasn't enough to even push it out.
And so that's just old sediment from the water
Mm-hmm.
previously. And then getting back real quick to the maintenance. So in a perfect world, how many Joes would you have out there? 2,
I'll
3?
take as many Joes as I can get.
Well,
I would say, you know, if we're running a park that size with the amount of people that we have there, and we stayed doing the contracting the way that we're doing, you know, that's a big factor too. You know, they mow the turf for us,
Right.
and that's the main thing. And then we do the lower level trimming. They trim the palms and stuff like that. But we do all the day-to-day maintenance in there. I would say if we had 2 there full-time, then that would certainly be a big benefit to that park.
well, budget talks are coming up, right?
Grady, thanks for the suggestion of the meeting. We meet with them regularly, and we speak with the sanitary district regularly, and I've never felt a problem with communication at all, or willingness to talk to us and us to them, and we all just need to be clear about the things that we want to do together, and I have no doubt that we would all be united for our shared constituency, so look forward to moving forward with that. Any other, yes, Councilman?
So do we have a Councilman Brown's question? Did we have a figure of what it was for the? It's about 1.5 million? You're gonna have to keep blowing out lines, brother.
So, I'm not sure if Dennis heard that. Dennis, did you hear it's 1.5 million?
Okay, let's move on. Thanks.
All right.
Thank you very much. I'm sorry, I only brought Kevin up because he had some of the operational side of things I thought was helpful.
No problem at all. He knows firsthand. So I think that concludes our irrigation system discussion. So I'm gonna hand it back over to Mike. Thank you.
All right, very good. So with that part out of the way, we'll go to the electrical and instrumentation control system discussion as well. So some of the equipment that we looked at there ranges from the utility metering section to the transformers and switchboards and panel boards and other things that provide power to the pumps, and even down to the instrumentation, as we've talked about a little bit there already. So the first thing we did want to touch on was something that's not actually installed currently, and those are variable frequency drives or variable speed drives, also acronymed as VFDs, or adjustable frequent drives, AFDs, as you might hear. Currently, the pumps are directly driven, so they're called to turn on. They just turn on, they ramp up to their full speed, and then after the 15 minutes that they run, they turn back off. So I know there has been discussion in the past about the potential of installing variable frequency drives on these from an energy standpoint, savings standpoint. And we looked at multiple things associated with it, not only the capital associated with purchasing new VFDs and installing them, which kind of has a domino effect on some of the existing electrical equipment that's there, but also on just the timing of when a variable frequency drive would be used by these pumps. So typically, right now, if the wind was nice and calm, the pumps would turn on and they would ramp, even if they had a VFD, they would ramp up to 100% speed and they would stay there for the time that they were on and they would just turn off. The only time that a variable frequency drive would be desired would be to try to match the speed of the pump to the wind speed of the actual environment to prevent drift of the fountain. So when you consider that these pumps run 3 hours a day total, and that most of the time they're operating at 100% speed anyway, whether it's one pump or two pumps, depending on the wind speed, And then you throw in the fact that they're pretty intensive capital-wise to install. The equipment where you would need to put them inside, because they need to be installed inside, you'd have to take the existing electrical equipment and buy a new one and put it outside, and then do all the cable and conduits, and then upgrade the HVAC system in the room, because there's additional heat that's generated by those when they do. So there's just a lot of extra things. And when you do the payback period on that, it just doesn't pencil out. So we don't recommend putting in VFDs on these pumps. And if for whatever reason you did change the duration that those pumps run, then that might be something to look at again. But even then, I still think it would be difficult to get that payback period just for the typical lifespan of a VFD themselves. So with that, that's a zero cost option that is nice. So with that, I think a more economical way of being able to help from a control standpoint would be to look at how the control system of the fountain system is being done right now. And you see that inside this control panel is just a little controller there, and it's pretty basic. It works, it runs, but it doesn't really communicate to the outside world. So in order for Kevin and his team to understand what's happening, you have to physically go over there to see what the problem is. So our recommendation would be to spend some money to replace this basic system with a programmable logical controller, a PLC, which would be able to provide Kevin and his team, from an operations standpoint, real-time information about the status of the pumps when they're operating, the status of the check valves when that switch has been made or not made. And if you also add a cellular link to provide that information, similar to the cellular link that you already have out at the, I think there's a restroom and office building or structure that you have in the park. It's a similar type of thing. It would just be a second one that would be added. That information can be relayed real time, and if you wanted to also, say, link it to the town network and put it on the website, you could interact directly with the public at that point and say, hey, the wind speed is too high, the pumps will not be running for the next, whatever period of time. So it's a little bit more interactive that you could make with some fairly low-cost option, certainly in comparison to the VFDs. Any questions on that? Okay, very good. So from that standpoint, we'll move away from the instrumentation and control into the motor control center, the motor control lineup. In this case, you can see in the picture that this is an aged piece of equipment. It has exceeded the typical life expectancy and doesn't have necessarily all the safety features that a modern piece of electrical gear would have. There are different alternatives associated with that. It is, and Councilman, you had mentioned, is like, when is it going to fail next? This is not a necessarily imminent failure, just because the maintenance that Kevin and his team has done regularly every 18 months or so, they don't make these like they did, or they don't make them now like they did then. So from that standpoint, the frame and the perimeter, the enclosure itself is in good shape. What we would recommend is continuing to do that routine maintenance until you get to a point to where you say, all right, hey, this is, everything will at some point reach the end of its life. So what we did find out, though, is that you don't necessarily need to do a full replacement of this entire piece of equipment. There are refurbished kits that can be provided that would take not necessarily entire things. So there's, it gets power from the upstream piece of equipment, and that piece of electrical gear that would remain, but everything that connects to it that goes and powers each of the motors would be replaced. And from that standpoint, that can be a cost savings initially.
Clearly, we don't want to wait, we don't want to wait till things fail.
Correct.
But how do we know? I mean, can Kevin tell from looking at certain equipment? Would you come in periodically? I mean, how do we know that we're reaching the point where we really have to do something?
That's a good question. So a lot of what is done on that regular maintenance schedule, they're able to tell just from how the cable looks, if there are any you might get some arcing at some point where some of the insulation, either in the cable or in the actual piece of equipment itself, might start to show signs of age from that standpoint, from an electrical side. So if that regular maintenance is done and is able to be, I guess that would be just a means of providing you some comfort that between now and the next time that you need to service it, that it should meet that time.
I'm not looking to spend money, but.
Correct.
That's for sure. Should we consider having you folks come in quarterly, semi-annually, whatever, to check out some of the things that are on the, the numbers for number 4 and 5?
Certainly, that wouldn't be an issue. We'd be happy to do that. But I'll be honest, for this case, there are very specific specialty firms that's what they specialize in. And that's who Kevin has coming out and doing that servicing. So we would recommend just continuing down that path. We can do the overall, like a spot check assessment or reviewing the reports that they provide. I would say that while this is a piece of equipment that could still run for the foreseeable future, it is something that you would want to put in the budget to say, all right, hey, try to be proactive with it. And especially from the safety standpoint, because as I'll talk on the next slide, we also did, and I guess I can go to that one right now if we wanted to talk through that. We did an arc flash analysis as well as a short circuit analysis. And what that arc flash means is that if you have to, certainly we would advocate if you had to do work on the equipment, that you would just turn it off, right? Turn the power off to it so that it's not active. However, if there was a need to perform maintenance on that equipment while it was still energized, this arc flash analysis will tell you what that hazard is, and it tells you how far that energy, if something were to fault, how far away from the front of that equipment that energy would actually go. And there are definite suits and protective equipment. Everybody's familiar now with the term PPE now with the pandemic, but there's personnel protective equipment specifically for working on electrical equipment while it's energized. And there are different levels of energy based on the assessment that we've done. So in one of those things, you can see the label at the right, tells you all of that equipment, or all that information, what the voltage is, how far that boundary is that you need to be in that suit if you are performing work on it while it's energized. And one of the code requirements from an electrical code is that all electrical equipment should have a sticker like this so that anybody coming up to it would know what that incident energy that they would potentially be exposing themselves to if they opened one of the panel doors while it was still energized.
Is that covering the page before that says lacks modern safety? Is that the issue?
Part of that is that with the modern safety piece is that a lot of, if you were to look at one of those individual, say, supply to a single motor, you could turn that off, but as soon as you open that gear, there's nothing preventing you from touching the ones on either side of it that still are energized. So the refurbishment equipment that would be that is available would decrease the possibility that you would expose yourself to something that would be energized if you're only working in one section.
So would that be part of the recommendation on this next page then, or is that in addition to?
The recommendation for the refurbishment of the equipment is separate from this. We've already done the assessment. All we need to do now is just print the labels and put them on the equipment so you know what's there. If other equipment is replaced over the course of time, like a transformer or one of the other piece of gear that's out there, you would need to revisit this analysis and put a new sticker on it based on what information was actually installed. The only other thing that I'd mention on this slide in particular is the short circuit analysis. So just like if you plug something or too many things into your outlet light socket, you want the fuse to trip in the fuse box, not the entire fuse box in your whole house. So what we found was that all of the electrical equipment that you have installed right now is adequately rated so that if something, an individual piece of equipment trips, the next piece of equipment that's supplying the energy will do its job and fault first without making the entire station go dark. So that's the main summary of that. So those were the things that we did want to highlight. Again, there were a lot of other pieces of equipment that we did assess. We can talk about those or any of the other ones that you'd like to, but I'll just do a quick conclusion. Was that, again, in general, there's a lot of equipment that's out there that has reached the published manufacturer's recommendation for its life. But again, it's the job that Kevin and his team have done to keep that equipment in good working condition and continue to do the annual maintenance, or the recommended maintenance has been good to the point to where there's very little that would need to be in immediate need of replacement. But as you said, Councilman, that you would need to start doing that planning because there are some fairly large expenditures to be able to replace that equipment when you want to replace it, not when it decides to replace itself. Some of those immediate recommendations, we kind of already talked about those, the check valves. There are 5 intake screens on that, on the inlet of the pump station that's in the water. The one that's damaged, we would certainly recommend that be repaired and replaced. We'll finish out the project right now and put the arc flash labels on the electrical equipment. And then again, just instead of putting the variable frequency drives on the pumps, but to be able to upgrade the control system to a PLC so that you can have that opportunity to, I mean, shoot, Kevin could probably control the pumps from his phone from somewhere else if we decided to program it that way, but also provide that interaction to the public if that was so desired. So those are those immediate recommendations. And from a next steps from our study standpoint, as Grady, as you mentioned, that we're looking at the logistics of how do you replace that liner. The liner's in good condition now, but what happens when it does need to be replaced, when you can do a periodic test of the evaporation, and if that starts to diverge or go the wrong direction and appears to be doing, it may be leaking, then at that point, what do you do? So certainly 20 years ago, there were a lot fewer residents, and how the 100 million gallons was disposed of is not necessarily the same option that's able or available now. So from that to any of the solids that are there and the aquatic life, and all of those things are questions that we'll look at and we'll come back and talk to you about at a later date.
As you might expect, the liner is our #1 concern.
Correct.
Because of the cost of removing the water and everything, all that has to do with, you had divers go in, you said it's in pretty good condition. Give any idea as to how long you think it would last?
Well, I think between the 20, 30-year mark is the typical for that type of a liner. We're at that 20-year mark, so it's good that you do that, have done that assessment. And certainly, doing every couple years sort of a dive, having a diver go back and look at those similar spots to see if they see any difference in that just over the course of time and trying to document that would be, again, try to give you that ability to see if something's happening quicker than not. At this point, we don't see any indication that is happening at all, so that it should be able to go for a good
Brady,
amount
we
of
did an
time.
assessment, correct? We did an assessment of the liner.
That's what these folks did.
Oh, okay.
That's
all
what
right.
we did, yeah.
Okay.
Yeah, thank you, Mayor. Are you sure more stickers just wouldn't help all these other things as well? Because, I mean, we'll give you all the stickers you need. That would be awesome. Couple things. I mean, the immediate recommendations, I agree with those. I think that's a good, first step. And I know we're going to dive deeper into some of the costs and priorities and budgeting and what comes first and all that kind of thing. I think the news on the liner is actually good news. I was quite encouraged by that to see it's in really good shape. I think we're, buying some good time there, and I know we need to start planning for whenever that occurs, and don't want to discourage that, but I don't think that should be our highest priority either. I mean, I think we need to plan for it and figure out, rough estimates, that kind of thing. But to me, from a general public standpoint, the citizens, it's the quality of the grass, the picnicking, the festivities we have down there, the smell, what else? The poop on the sidewalk, all those kinds of things. And so I think, 1.5 for a whole new irrigation system is a lot of money. But I think we should plan for that almost somehow soon, just because I think that'll help take care of the turf issue and the look of the park, and just from a public standpoint that are down there every day using it. I think the fountain itself, the lily structure, the pumps, the mechanical, electrical equipment, obviously we want the fountain to keep running and look good as well. And I think it sounds like a lot of those things we can kind of piecemeal in and improve them as we go along in the next, 2 to 5 to 10 years. So I think that's encouraging as well. I just, and I think we've done a lot better on the water quality too, and the smell. We have the aerators in there, so we need to keep that up, and the chemicals and all that kind of thing. But obviously talking to the sanitary district, trying to prioritize some of this, but I just see, kind of the quality of life, quality of usage of that park is kind of the priority, because it's a public park and it's well used, and I think we need to keep it as pristine as we can, given our budgetary constraints. That's just kind of how I look on it. And there was one other thing, and Rachel, maybe this one's for you, in the master plan study that's going on right now. Fountain Park is in that. We're gonna, maybe get some conclusions there. Has anyone ever looked at reconfiguring just some of the grassy areas? So maybe areas that we're having issues with, maybe, we can't do decomposed granite because that'll just all end up in the lake, but maybe some pavers or picnic areas, or just something different than the crappy grass that's so prevalent out there. Just an idea. It's more money, I know, but long-term might save headaches.
To my knowledge, there's been a couple of different versions of what it could look like down there. A number of years ago, there was the downtown plan. There has also been discussion of maybe adding some additional parking areas to increase accessibility and things like that. I know Kevin, who has done a phenomenal job working towards improving our parks, has really taken it as a personal mission to grow some grass where we traditionally haven't had it. So he's taken that sort of as a personal challenge. But yeah, that's certainly something we can consider down there. Again, it all has a cause and effect in terms of where and how we do that, and what does that look like in terms of usability, and
Right.
whether it's for open space and activities, or whether it's for festivities, like you mentioned, and things like that.
Yeah, I mean, I don't want to change the nature of the park per se, but I think whenever if we replace the whole irrigation system, that might be something to consider in terms of
Absolutely.
throwing some different things here and there without, massively changing the usage.
Sure. I'll share that, Kevin doesn't get a whole lot of chance to talk about the skills that he puts out there for our turf and maintenance. So one of the projects he took on this while most of us were at home during quarantine, our park staff were still here. And they took on a project to rehab Field 1 over at Golden Eagle. And in so doing, they took out a bit of turf over there. It was in good shape, good quality, healthy, and so they did redistribute it at 2 other parks to help fill in areas where there is some deficiency, specifically by the amphitheater area. So that was just starting to fill in, and then obviously we're in overseeding now, so it'll go dormant, but the hope is that as that comes back in the spring and warmer months, we'll start to see improvement over there, as well as over by the Euro Pizza kind of splash pad area as well. So he's done a great job really trying to utilize what we have and then make improvements where and when possible. So the other thing I was going to add, and Mike, thank you for talking about the liner. Councilman Magazine, we did, most of us, me included, weren't here when the liner was replaced in 2000. But what we did hear recently, just through some anecdotal information, was that at that time, pieces of the liner were actually floating to the surface. That there was definitely indicators that it was time, among others of like leaking and things like that. There's definitely visual cues that replacement needed to happen. So we're hopeful we don't have to get to that point, but regular inspections should help us with that as well.
Councilman?
Thank you, Mayor. Well, obviously, this is the focal point of the town. I mean, we're named Fountain Hills. Is there a way, Grady, of possibly putting together like an all-encompassing bond package that we could float? Because, I mean, I've discussed this with Rachel, that the splash pad is $500,000 and it desperately needs to be replaced. It's wasting water. So, I mean, we have $500,000 to regenerate the splash pad. To fix the irrigation system, we're talking on $1.5 million. I mean, it seems like what we should do, if possible, is to put an all-encompassing package together that would fix the splash pad, the pumps the way they should be, get rid of Bela Lugosi's chamber of electrical horrors, fix that so we don't get, somebody goes down there and gets killed and we get a 1.5 for $2 million lawsuit for killing somebody. So, and then, I mean, just do an all-encompassing package, get a total to the council, and then, I mean, I can't see the focal point of the town.
So you're actually right on. We were hoping this year would have been the year that we would have been able to take a street bond package to the voters, and then we had this whole COVID situation. So we're a little bit behind. You can only do bond packages to the voters every even year. So it's 2022 would be the next time we can do this. Rachel and I have talked about having the splash pad be part of an improvement, as well as the other improvements at the park. Just before this meeting, there were a few of us that were talking about that this could possibly be a combination of different things. It could be a combination of cash that we have maybe in the capital. It could also be some of I've asked our finance director to look at the Municipal Property Corporation, which is how we financed all these buildings here. It doesn't require a vote of the public. It's something that this Municipal Property Corporation can recommend to the council. Works like a lease purchase. So I've asked the finance director to see what types of facilities under state law we can do. And then you finally have, to your point, a bond. So I think it might be a combination of all three to kind of keep the load on the voters or the potential payers a little bit lighter. But absolutely, we know that the splash pad, because it's water and it gets a lot of use, and it's used every day from April through October when it's in use. So it definitely needs to be replaced. So absolutely. And I think we'll get more into these kind of discussions when we do the capital improvement program budgeting. And this is very helpful because with the sequencing, well, with just the prioritization that they just shared with you, with the near term and intermediate terms, and then a little bit more longer terms, we can actually plan for some of this, and it's not as bad as it potentially could have been. So, but good points.
Thank you. I agree with that. Obviously, this big picture, looking at things like that is really, really important. And, you know, we were talking even a little bit about what you were saying, and not to take turf away, but, you know, if you have maybe where some paths are, and maybe you end up having a little bit of granite around it or something, to, in the long term, would make it less of something that had to be, you know, kept up with. But this is exactly the kind of thing we're looking for and hoping for, that you would look ahead and see what is something that really means a lot. You know, yes, it's our name, but what is it doing? It's a center point of our town. It's a place where folks like to go. Finally, you know, the algae, the water quality, I mean, everything. And obviously it's going to cost a lot, but having the liner not be this imminent part of it really makes it something that we can really look at. But like Grady said, though, November 22, and then of course we have road issues, like we all know. So a lot of discussion to have, but yes, sir.
Since the good news on the liner, we all appreciate that, but so we have maybe 10 years of useful life left on it. Is that something we start planning for now, putting some money away toward the liner replacement? So that
Yes, that's why we're doing this study, because absolutely, we need to be, the logistics, as we'll get into it when they come back for the part 2. It's going to be, we talked a little bit about this before the meeting, it's going to be very complicated, very expensive, and I think the liner is going to look like a walk in the park compared to, sorry for the pun, compared to the liner replacement itself, because it's got a lot of different challenges associated with it. And part of the other issue is, if you have that lake fully drained and you're replacing the liner, we don't want all the vegetation and the grass and everything to die. So that's where this whole storage system comes into play as well. We want to be able to irrigate. So all this is kind of all in a sequential order, but they're going to help us figure this out and give you a menu of options. And then we can start planning for it budgetarily.
Good, thank you.
Well, thanks again. Are there any other questions or comments? We really appreciate it, this specialized professionalism that you have, and really helping us out. And thank you to our staff and everybody that's working so hard on this, and look forward to our next steps.
Good, thanks for the
Thank
opportunity.
you. Speaking of, our immediate next step is to look at those check valves. Rachel?
All right, not to belabor the point, I know we talked about the valves quite a bit in our previous presentation, but the next item on our agenda is requesting permission to move forward with the purchase of the check valves. As you know, we've been working with our vendor to identify the proper replacement, one that should give us the longevity that we'd like to see. The request right now is to proceed with the purchase of the 3 replacements at the cost of not to exceed $85,000. We do have an estimate on the pumps, the valves. That does not yet include the installation, so we wanted to make sure we had the window of funding there to do the install. We do have the funding allocated in our facility replacement budget, so there is funding there available for this purchase. The one real consideration we want to keep in mind is that 2 of those 3 valves are currently failing right now. So that means that the fountain is only operating on 1 pump, period. And it cannot operate on any additional pumps until we do this. The other sort of whammy here is that the replacement window, or the manufacturing window, is 18 weeks to get these. So time is not on our side, so we would like to move forward with these as soon as possible. Any questions?
Thank you. Any questions?
I have a quick question.
Yes, Vice Mayor.
Sort of related, the screen that needs replacement, what's the timing on that? Because we don't want any more big fish getting up in the pump, so.
We certainly don't.
Yeah.
I think what the plan was to actually continue working with Black and Veatch and the diving company that did the assessment, because we will need them to actually go down and do the repair for us. So we'll need to work with them to get the estimate on what that is and when we can make that happen. But that is a priority for us as well. We're hoping that we have the funding available already and don't need to come for a special permission on that one. But
If we can do it administratively, we'll do that and we'll let you know, because that will save time if we can get moving on it.
yes, but I don't have an estimate yet on what that cost will be.
Well, I know Councilman Spellage is a diver, and I think he's volunteered his time to go down there. I'm just passing that on, so.
So if there's no further discussion, can I have a motion?
Move approval.
Okay, I'll just going to say, move to authorize town manager to proceed with procurement and installation of 3 check valves for the fountain in an amount not to exceed $85,000. We have a motion and a second. All in favor, please say aye. Aye. Any opposed?
Did you want to do voice so you know who on that?
I don't think anybody's on the phone. Yeah. You want to say something now?
Yeah.
Okay, Councilman.
Well, I just wanted to thank the gentleman because I thought this was an excellent presentation. If I can begin to understand 25 to 40% of it, it had to be good.
Thank you. Thanks again, everyone. Can I get a motion to adjourn? All in favor, say aye. Aye. Thank you. Good night.